Why hello, welcome back to some geometry videos. In this video we're talking about some special right triangles. In this specific one it's talking about the 45-45-90 triangle. That is a triangle that has two 45-degree angles and a 90-degree angle. Now hopefully you've already learned that if a triangle has two angles that are equal, that triangle is an isosceles triangle. Because if you have two angles that are equal, that means the sides across from them must also be equal. So which is why these special right triangles that are 45 degrees, and 90 degrees are sometimes called isosceles right triangles, because it has two equal legs. So it turns out that special right triangles are called special because they have very unique side length relationships. So usually we call these things the legs, so this is one leg of the special right triangle. And it turns out because it's isosceles, both of these are the same exact length. So this says if this has a length of 9 units, then this also has a length of 9 units. So the legs are the exact same. And if we apply our Pythagorean theorem to find out what the length of the hypotenuse is, it turns out that if we do leg squared plus leg squared, that needs to equal the hypotenuse squared. So here we have some like terms. 1 leg squared plus 2 leg squareds is, 2 leg squareds. And finally, if we take the square root of both sides to isolate our variable c, aka our hypotenuse, if we take the square root of both sides, here we have the square root of a product. And what is allowed to happen is I can take the square of each of the products separately, and that turns out to be the same thing. So this term, the square root of leg squared, is just the leg length. This one, the radical's gone, the square's gone, and we are left with root 2. So it turns out, according to Pythagoras, regardless of whatever the legs happen to be, the hypotenuse is whatever the leg length is times the square root of 2. So, if, in general, if I happen to have myself an isosceles right triangle, and I had a leg of 14, that means my other leg would be 14, and I could spend a lot of time, if we wanted to, using the Pythagorean theorem in order to figure out the length of the hypotenuse, but because of this relationship, the legs are always the same, and the hypotenuse is whatever the leg is times the square root of 2. So this length is 14 times the square root of 2 units long. Now yes, that doesn't mean a whole bunch, but that's exactly what it is. So this is called a radical form. We're going to leave all of our answers today on this video in radical form, simplified radical form. Okay, we could use our calculator, of course, and approximate this. Let me exit this mode. So 14 times the square root of 2 looks like it's 19.7989 is the actual length if you want a decimal equivalent. If we were going to go to the store, it's hard to buy something with 14 square roots of 2 amount of money because we don't really know how much that is. So it turns out that that is equivalent to or similar to 19.798 units long. So approximately 17.799 if we round to 3 decimal places. Okay, this is a more usable number. If you were going to be cutting wood or something, you would want to have a decimal equivalent to see exactly how far, how long you have to cut. But for us, 14 roots of 2 is an exact measure, and it's perfectly good. Okay, it's not true easy to understand, but it is a good answer. And lots of SAT, ACT things leave answers in radicals rather than just decimalizing them. So let's do some problems and see what we can get here. Okay, find the missing side lengths are going to be the directions to almost all of these problems. So we notice that this is a 45-degree angle here, which means this also has to be a 45-degree angle. So you have your special right triangle. We know that whatever this leg is also, so that's also 9, and the hypotenuse is 9 times the square root of 2. Done. That's all there is to it. So the special right triangles are supposed to be able to speed up your calculations by knowing the relationship rather than having to calculate the relationship. Let's see, find the missing side. Here we have 17. The other leg is going to be 17, and the hypotenuse is 17 roots of 2. Okay, so anytime you can pause the video, okay, especially at the beginning of a problem, and try to figure it out yourself, and then press play so that you're able to see if you got it right. Okay, like for this one, here we have a hypotenuse of 13 roots of 2. So if you want to pause the video, go ahead and pause it. I'm just going to keep talking, so just hit the pause button. But we know that the hypotenuse is whatever the leg happens to be times the square root of 2. So here, this matches up, this matches up. That means your leg has to be 13 units long. Okay, rather than doing x and using Pythagoras to figure out what the legs are, we know the relationship. The hypotenuse is the leg times the square root of 2, so this must be the value of the leg. And you're done. It's supposed to make it simpler and quicker. So here we have radical 13. So a little bit of here we're going to do some radical operations. Okay, the square root of 13 is this length, which means this length is also the square root of 13. And this length is the square root of 13 times the square root of 2. And as we talked about before, if we have the multiplication of two radicals, that's the same as taking the radical of the multiplication. Okay, these two are mathematically equivalent. So we can do this multiplication underneath our radical, and that is your answer. The square root of 26 is the length of the hypotenuse of this special 45, 45, 90 right triangle. Okay, so try this one, press pause, and then come back. So one leg is 4 roots of 3, that means the other leg is also 4 roots of 3, and the hypotenuse is 4 roots of 3 times the square root of 2. So root 3 times root 2 is the square root of 6, which is not simplifiable, so we leave it just like that. 4 roots of 6. Excellent, good job. Let's see, here's some more. Oh, now we know our hypotenuse is 5 times the square root of 22. Okay, so pause the video and see if you can figure out what the lengths of the legs are of this 45, 45, 90 triangle. Well, we know that this is something, whatever the leg happens to be, times the square root of 2. So the question is, root 22 is what times the square root of 2. Since you know radicals multiply to other radicals, you're going to have to figure out a radical times what is root 22. And I think we're figuring it out because we need to have an 11. 11 times 2 is 22. So I'm going to break this into root 2 and something. So 2 times something, 2 times 11, which means 5 roots of 11 is going to be the length of our two legs. Because the hypotenuse is leg times root 2. So we have root 2, this has to be our leg, these two things multiply together to give us 22. Okay, so you need to know a little bit about radical operations in order to be able to multiply radicals or separate them in this case. Okay, so here's a unique situation. This leg is 7 roots of 2. Our other leg has to be the same, so also 7 roots of 2. And we notice that the hypotenuse is whatever the leg is times the square root of 2. So in simplifying your radicals here, root 2 times root 2 is root 4. But we know another name for root 4. The square root of 4 is actually the number 2. The square root of 4 is the value 2. So in this case, if you have two numbers that multiply together that are the same, root 2 and root 2, you actually just get the radicand there. So root 2 times root 2 is root 4, and the square root of 4 is 2. So this has a hypotenuse length of 14 units long. And you will normally find if this is a radical with a root 2 on it, your hypotenuse is not going to have a root 2. Okay, so another one. Here we have 3 roots of 2. So pause the video, figure it out, and then come back. Here's 3 roots of 2. That means our other leg also has to be 3 roots of 2. So our hypotenuse is the leg times the square root of 2. So once again, I'm going to simplify this. Root 2 times root 2 is the number 2. So 3 times 2 is 6. So the hypotenuse has a length of 6. Okay, so notice the relationship. Here we have a 3 root 2. Here's another 3 root 2, and your number is a 6. So 3 relates to 6. Okay, back here, we had a hypotenuse of 14 and a leg of 7 roots of 2 and 7 roots of 2. Okay, it turns out this is always going to be the case. Okay, if we have a whole number hypotenuse, and this is a special case, then we have to do 2 things. We have to divide the hypotenuse by 2, and we have to multiply by root 2 in order to get the leg. Okay, always, which is why these are special, because it always has this relationship, and it's only good in a 45, 45, 90 triangle. Okay, no other triangles in the world have this relationship except for 45, 45, 90s. Okay, so we have to divide it by 2, so 16 divided by 2 is 8, okay, and we have to multiply by root 2. So if a hypotenuse is a whole number, divide it by 2, multiply by root 2. Okay, because when you do it backwards, when you do 8 roots of 2 times root 2, that's actually 8 times 2, which gives you the 16. So if you have a whole number hypotenuse, divide it by 2, multiply by root 2 in order to get the leg length. Okay, so here's 32. Try this one. Remember, pause the video and then come back. So the 2 things we do to 32 are divide it by 2 and multiply by root 2. So 32 divided by 2 is 16 with a root 2 multiplied by it. And both of the legs are the same. Okay. So now here's a doozy. Here's the last one. Here we have 20 roots of 6. Okay, so we have to do a couple of things here in order to figure out what the leg is down here. So 20 roots of 6, we know this has to be something times root 2. It looks like this is 20 roots of 3. So the leg is going to be 20 roots of 3. Both of them. Okay, so even if it seems a little complicated and we're just going to halving it, but this one just has a root 6 in it, you just have to see what is the leg times root 2. So roots multiply to other roots. And it looks like that's the end. So remember, this is the more challenging one. When you have a whole number hypotenuse without a radical, you divide it by 2 and you take the square root of 2. So hopefully this has been informative and you know a little bit more about the relationships between 45, 45, 90 triangles and their sides. Thank you for watching.